Good afternoon, good morning, and good evening, wherever you happen to be. Thank you for joining us for today's webinar. This is a little bit different than what we normally do. Our webinar today is Q&A all around hyperconvergence. My name is Scott D. Lowe. I'm other Scott Lowe on Twitter, and I'm also the co-founder of Actual Tech Media. I'm joined today by Brian Knudsen, who is the technical marketing manager for Simplivity. Thanks for being here today, Brian.
Thanks for having me, Scott.
Today, we're going to, like I said, do something a little bit different. We do not have a prescribed webinar format that we're following today. Today's all about basically watching Brian and I as we have some discussions around questions that were actually asked in a prior webinar that we held on the topic of hyperconvergence. So with that in mind, let's get underway. The first question we have for today's webinar is storage plus is storage plus dense server considered hyperconvergence? Basically, the question that's being asked is if I've got a storage array and I've got a number of servers, is that considered hyperconverged? And the answer is absolutely no. The reason is when you think about hyperconvergence, it's more than just servers plus storage. When we talk about the various companies that are in the hyperconvergent space, including Brian with Simplivity's solution, there's a huge software component that goes into the hyperconverged solution. It's on top of the other components you would normally see in the data center. So when we start talking about the hyperconvergence, the hardware really doesn't play as central a role as it would normally play in a regular data center. Obviously, it's still critical, but what's really critical is to have the software layer that manages the entire environment. When you have just traditional servers plus traditional storage, you don't have that software layer. The benefits to hyperconvergence are really carried in the software layer, which aggregates all the various resources from those servers and presents them back to that cluster to be able to be consumed by virtual machines that are present in that cluster. Brian, do you have any thoughts to share on that particular question?
Yeah, I mean, the whole concept with hyperconverged is to squeeze everything together to reduce the management overhead, the management domains that have to be individually dealt with. So by collapsing servers and the storage together into one and eliminating essentially those individual LUN management and having to manage all those individual disks and creating LUN groups and all that kind of stuff is really the vision of hyperconverged.
Absolutely, and that's bringing simplicity to the data center, which has been often considered a chaotic mess by some, is one of the huge benefits of hyperconverged infrastructure. And that software layer is intended to address that very issue of complexity in favor of simplicity.
and there you know why we named the company the way we did.
That was kind of funny. Also, to the audience, I want to mention that if you have questions, please ask them in the questions pane. We have a number of questions from the previous webinar that we'll be going over in today's webinar. However, we also would like to see your new questions. So if you have any questions at all around hyperconverged infrastructure, please use the GoToWebinar's question pane to ask those questions. Now, the next question that we have, Brian, comes, and it's a good question. And basically the question is being 100% virtualized required in a hyperconverged infrastructure environment? And obviously, I think that as we look around the market, the answer to that is no. In fact, there's a question we'll talk about a little bit later, I think, that demonstrates some of the reasons why that's the case. But a lot of people have brought hyperconvergence in through specific projects like virtual desktops, VDI, or they had a specific need to be addressed. And maybe over time, they've kind of migrated other portions of their environment to the hyperconverged infrastructure, but they can coexist pretty nicely. Can you talk a little bit about that on your end as well?
Yeah, it's kind of the whole thing with, do you need to virtualize everything to take advantage of virtualization? I mean, it's essentially the same answer, is that whatever you can move into a virtualized environment or a hyperconverged environment is going to reap those benefits. But if you've still got a mainframe, if you still have a server that has to have a big old fax card in it, some other hardware requirement that's out there, anytime you have those things in your environment, they're always going to, for the most part, be islands, and they're going to stay islands because they kind of have to be. But the ability to be able to take everything else and put it into this hyperconverged environment can then benefit the company. So it may not eliminate or collapse everything down, but it'll collapse probably the majority based on the way a lot of customers are getting to greater than 50% virtualized.
And one of the things that's happening now is even in a lot of cases, tier one workloads, the ones that we're running in physical environments, are starting to be migrated into virtual environments as the hypervisor becomes more powerful, as people become far more comfortable with virtualizing things, and as companies start to loosen and continue to loosen their restrictions around what they're allowed to be virtualized. I mean, it was even with Exchange 2007, for example, Microsoft still wouldn't allow you to virtualize certain roles. But in recent years, those restrictions have been lifted, and that really helps to start move closer to the ability to be 100% virtualized. I think it's safe to say, though, that if you become 100% virtualized, you're going to gain even more benefit from a hyperconverged infrastructure because of the simplicity that it brings.
Yep. The advantages increase the greater the percentage of your environment, because it obviously continues to build upon itself in some regards, so that it's maybe even a little bit more than a linear increase in value as you increase the percentage of virtualization.
Yeah, and when people think about costs around hyperconvergence, I mean, one of the big costs that can be addressed is operational items that go into managing the environment. First of all, SAN is a huge cost for a lot of organizations, but managing that stuff is tremendously expensive in a lot of cases. So again, the closer you can get to that 100% virtualization mark along with hyperconvergence, the more potential benefit there would seem to be for the organization.
Yep, definitely. And if you can get to that magical 100%, or at least get to the point where maybe you don't have any physical servers that need a SAN type architecture, then you can really benefit from hyperconverged by eliminating the SAN management altogether.
Excellent. Again, please make sure that you ask questions in the questions pane in the webinar, and we're going to answer those as many as we possibly can during this webinar. In fact, let's take one of those questions right now, Brian, if you don't mind going off script a little bit.
Absolutely.
The question is, I heard about a new solution from SimpliVity and UCS. Is that an integrated product? Is it one SKU, or do I need to purchase them separately and run?
Well, it's a good thing I'm on here to answer that one. They are not one SKU. The partnership with Cisco and the UCS platform is meet in the channel type model is kind of the way that we term it. The idea being that you need to work with a VAR, value added reseller, that is both a Cisco partner and a SimpliVity partner. And what's going to happen in that situation is that VAR can then bring it to their customer as if it were one SKU, but in reality, it's two separate transactions, one to Cisco, one to SimpliVity. They do both ship to a SimpliVity location, and we pre-integrate, do all the pre-build, same stuff we would do with what we call our OmniCube, which is more of the appliance deployment type model. And then when it gets to the customer, it is all pre-integrated at that point. So from a customer perspective, it really is intended to look as if it was a single SKU, as if it were a single product. But in reality, it's really up to the VAR, the reseller, to be able to bring the solution together.
Excellent. Another question that came up in our previous webinar was, how can I leverage storage in the world of hyperconverged infrastructure? And this really depends on the vendor in a lot of cases. Not all vendors in the hyperconverged space support the same kinds of storage options that are available with other vendors. And what the question here is I believe, can I either leverage my existing SAN from inside the hyperconverged environment, or can I leverage the storage that's inside the virtual environment from systems that are outside the virtual environment? So for example, you may have, again, I'll use Exchange as an example. You may have a physical Exchange server, but you'd like to use the storage that's in the hyperconverged environment to store your mailboxes and stuff like that. The answer to that question is it depends on your vendor. Some vendors do support accessing that storage. In fact, I believe SimpliVity does this as well. You will allow people to access the storage that's inside the hyperconverged environment from outside the hyperconverged environment. And you can still set up any kind of iSCSI or NFS-based connections you want from inside the hyperconverged environment to a SAN that's outside the hyperconverged environment. Now, in most cases, you can't leverage fiber channel-based storage from inside a hyperconverged environment because there's not a fiber channel adapter in a lot of the appliances that come from various vendors in the
Correct.
hyperconverged space. So yeah, check with your vendor, but it depends on exactly how they expose the storage to their solution and to the external world. But I believe SimpliVity, are you NFS or iSCSI or both?
Um, Pretty much all the hyperconverged vendors are some flavor of NFS, VMware being kind of the notable exception there. Um, the thing to remember with them is even though they may be NFS based, they're all going to be the actual storage layer itself is going to be designed specifically for VMs. So to use them as a generic file server, for example, is generally going to be far outside the guidelines of any of the hyperconverged platforms. That being said, being able to run virtual machines on a non-SimpliVity host, for example, is definitely within the limits of our platform at least. So that's one thing you could bring in an HP server, for example. Maybe you already got it, you want to reutilize it. We would definitely accept that as part of the vSphere cluster as a whole.
Excellent, and that also addresses some integration opportunities. And a lot of people have questions around how do I get over on the hyperconvergence? I don't want to throw away what I've got. It needs to coexist for a period of time. So the more easily that you can integrate those components, the easier it is to be able to coexist and help people get the most value out of their old and new investments in their data centers.
Yep, absolutely.
Um, did you have another point?
No,
Okay.
that's all in line. And I guess if we want to expand on the question of how do I make the leap, because that's a pretty common question that
Yeah.
we hear.
Why don't you do that?
Storage is generally if there's one thing that we can drive in on more than anything else, it's usually storage. Simply because storage is such a big purchase, and really hyperconverged. The secret of hyperconverged really is in the storage layer across pretty much every platform. Being able to not only present that storage back to the vSphere host or the KVM host or the Hyper-V host, whichever virtualization platform is going on, but being able to protect that data both within each individual node and across all the nodes, and then in most cases across multiple sites, multiple data centers, is really the key to unlocking it. Like I said before, you're also looking to try and reduce, if not eliminate, a lot of the traditional storage management that you would have to do in a virtualized environment. So being able to not have to be carving out LUNs and then presenting those LUNs, but simply just to say, I need more storage, slap in a new host or a new node, and be able to have it automatically extend the space that's available to virtual machines just by doing that is really the big advantage. We do see server refreshes. Oftentimes servers and storage are going to come together and are going to be refreshed at the same time. That happens sometimes, not all the time. Occasionally customers will have pain points around backups or replication that traditional storage sometimes has a difficult time dealing with, where some of the unique features of hyperconvergence can come in and solve those as well.
Brian, we're going to take another question that we have from the previous webinar, but then we've got a couple that have come in that are really interesting. But I think the next one that we want to ask is a question on a lot of people's mind. And the question is, how does hyperconverged infrastructure address the I/O blender? And I'll explain that in just a second what the I/O blender is. Does it isolate the I/O to specific nodes? Does it do storage quality of service, or does it do something else? And for those that don't know this, the I/O blender is kind of a phenomenon that's taken place as we've moved more heavily into the world of virtualization. If you remember way back in the days of the physical server, you could basically define and create storage any way you wanted. So if you had a database server, for example, you'd have your log files on one kind of RAID, you'd have your database files on another kind of RAID, and that RAID would be tailored to the I/O patterns that are inherent in the database versus log file situations. However, when we've moved to the world of virtualized environments, we've sort of dumped it all out onto the storage network and said, figure it out. And that's basically mixed a lot of very different kinds of I/O patterns that sometimes can have a negative performance impact. Brian, when we talk about the I/O blender, how does a hyperconverged environment help address solving that challenge?
Those that particular challenge is solved differently in different platforms, so it's hard to say very generically. Storage QoS is a big one that some platforms will do. You're seeing that show up in some of the traditional storage vendors as kind of key features that some of them are, some startups are building based on. We created a QoS, and that's where we built our storage around. One advantage that Hyperconverged has over traditional storage infrastructure is the locality of the I/O. So in Hyperconverged, one of the advantages is that all of the disks are actually in the compute nodes. So the need to go across any sort of wire, whether that be glass or it be copper, is essentially eliminated unless you're having to go from one node to another. In pretty much every case is going to be a 10 gig connection at that point. And oftentimes that's usually just for protection of the data more than anything else. Most of the architectures, it's not going across the wire for read data, or there's some level of cache that reduces the amount of that happening. So I can't speak to every platform, obviously. I guess, Scott, do you want me to talk to how SimpliVity deals with the I/O blender?
Yeah.
Okay. So for us specifically, SimpliVity, again, going back to Hyperconverged, is generally about storage. SimpliVity was built around the storage problem. This storage problem and the one that the performance needs outstripping or being outstripped by the capacity. Capacity is increasing, storage performance is not. 15K disk hasn't gotten any faster in the last few years. To be able to really solve that problem, when SimpliVity was founded, was around the idea of let's eliminate I/O. To make the disks better, to make them perform better, they've got a limited number of IOPS, and to make them perform better, we need more IOPS. And in order to give more IOPS to a platform that can't have any more IOPS added into it, short of massive scale out, which is expensive, what you do is you eliminate the IOs that are coming into the system to begin with. So as VMs start to write, the SimpliVity platform will capture those writes and analyze them. Can they be deduped? Can they be compressed if they can't be deduped? And then optimizing them, lining them up so that the writes and the reads to and from the disk are going to be as efficient as possible. So as I/O comes in, we expect pretty much consistent random I/O. I mean, any platform built for virtualization from a storage perspective is essentially built with the understanding that it's pretty much pure random writes. So we capture all those, and if we can dedupe it, we never touch the disk. It never actually goes down to disk. Thereby, saving an IOP for every single write that can be deduped. And those that do have to go down and get compressed, they get optimized. So from a SimpliVity perspective, that's fairly unique in what we're doing there in order to solve that particular problem.
That's a good answer, and that's I've heard that question from folks as well before. Is how do we solve the I/O problem? And one of the I think biggest benefits of the SimpliVity platform, I'm familiar with pretty much with most of the platforms, but the SimpliVity's platform, oh my God, SimpliVity platform's data deduplication techniques are really second to none in the market right now. And again, the I/O reduction is a huge way to be able to gain some additional performance benefit from the solution. We're going to take a question from the audience now, and the question is how is high availability affected by a hyperconverged setup? I mean, with the use of the data store heartbeats, etc., is there a single point of failure anywhere that can affect high availability?
So that one, again, is going to be very dependent on the platform and how specifically the storage is set up. Could also be dependent on which hypervisors in use. So obviously, vSphere, if you've got the HA capability, is going to work the way that it does. in a SimpliVity type platform, we do rely on vSphere HA. So from a VM, restarting the VM, we rely on vSphere to do that, and it's very good at that. We didn't see any reason to have to rewrite anything there. From a data store perspective, vSphere uses data store heartbeats to answer that one specific topic. So we would, we configure based on that. From a protecting the data perspective, again, data was the number one thing we were trying to fix and solve and make better, make simpler. So we make sure to protect the data on multiple layers. So locally on disk, we can sustain the loss of at least 2 disks, and still be able to still serve data and not lose any data in that regard on a single node. Then we protect by all data is for every VM that's stored on a second node as well within one data center. Using our backup functionality, then you can send backups to remote sites. So now you can protect across multiple sites at the same time as well. And within those sites, the data is going to be stored in 2 different places on 2 different nodes. So it means stored on 2 different nodes, and within each node, it'll be able to sustain the loss of at least 2 disks. So being able to protect the data and make sure that it doesn't go down is paramount. The single point of failure part of the question, we can, depending on how big the cluster is within a data center, determines how many nodes you can lose. It goes from, we can lose 1 node in a 2-node setup, we can lose 2 nodes in a 3-node setup, et cetera, et cetera. Essentially, we always want to have an 50% or greater, and theoretically we can lose anything up to the 51%. And still be able to serve data. You may lose some VMs depending on how things are structured across the different nodes, but that's devil in the details at that point.
And when you say lose, it's basically become unavailable. There's not a data loss event.
Correct.
Okay.
Yeah, and generally speaking, and you see this, I know specifically in vSAN's architecture as well, that there's an assumption that after a certain amount of time, the node is probably going to be recoverable, because most outages are usually caused by, we failed a power supply. We get the power supply replaced, and it gets back up and running. We lose a CPU, and it causes the whole server to go down. Well, once we replace the CPU, everything else is going to come up. So there's some built-in assumptions that, hey, we're not going to automatically start rebuilding everything just because we lose a node for 10 seconds. That goes into the efficiency of the I/O. It goes into not causing more work on the platform than needs to be done.
Okay. Brian, we're going to go to another question that we have from the previous webinar, and it's, for disaster recovery, do you need SRM, or does SimpliVity provide this functionality within their software? This was a question from the audience from the previous webinar, and since you're here, I thought, let's ask it.
Good deal. That is a great question. We do not need SRM to do DR. Currently, DR is based around our built-in backup functionality. So without getting into the deep, dirty details of how backups and deduplication work in our platform, essentially we can, usually within seconds, have a backup created in a remote site. So depending on how often you schedule backups is kind of gets you to your RPO aspect of it. RTO is very quick. To rehydrate a VM from a backup is really just taking a set of blocks that already exist, and instead of pointing to them and saying this is a backup, we point at them and say this is a VM. So being able to reinstantiate that backup as a VM is a matter of seconds. Usually the longest part of the process is just getting vSphere to recognize that, hey, there's a VM here, register it, and then it's a matter of powering it on at that point. And that can all be scripted out, of course. So today, we don't have direct support for SRM. I don't know that any of the hypervisor platforms have an official VMware certified SRM plugin. I know that we for sure don't. But that's because we don't really fit into the normal model of SRM with one level replication.
It's also one of the questions we got from the previous webinar is what are RTO and RPO? And I'll take a stab at those.
Go for it.
RTO, when you think about that in terms of data recovery, is known as recovery time objective. It's basically after you have an issue, how quickly do you need to recover? And that's basically a business-based decision. The business says we need this much, we have to be recovered in this amount of time if we have a disaster or some kind of other outage. And then if depending on the shorter the length of the shorter the RTO, the often the more expensive the infrastructure that has to be behind that to support getting back up and running very quickly. RPO is recovery point objective, and that's basically a measure of how much data loss are you willing to suffer. And I'm not crying because of data loss, I'm crying because of allergies. But so if you actually have a data loss event, let's say that you have, let's take the example of doing nightly backups. Basically, if you just back up overnight, you're implicitly saying that you have an RPO of 24 hours. You're willing to lose the last 24 hours worth of your data if you should have a disaster before the next backup kicks in. That's one of the reasons why we see people moving to more real-time type backup opportunities, implementing more of a replication-based methodology for some of their data protection, because they want shorter RPOs so that the risk of data loss is not as great. Do you have anything to add to that, Brian?
No, that pretty well nails it on the head. I mean, anybody that's going into a DR planning, that's the very first thing you need to identify per application. What's the RTO? What's the RPO? And that everything falls into line fairly simply after that, because those are really the two key metrics that get most customers hung up.
This is a really good question that came in from the audience, Brian. It says, since you don't have to segregate the log files from the random database files in a hyperconverged environment, should you just create a virtual machine with a single volume? Is it beneficial to continue to separate the OS from the data from the log files?
So yeah, I definitely hear that question a lot, and that's becoming more and more common as we start moving SQL and Exchange and those higher end applications into a virtualized environment. In all reality, from an IO, from a performance perspective, there's no reason not to do it that way. It's all going to the same set of disks. It's all going through the same set of protocols, same set of path to get to the disks. And I'm talking generically in a VMware perspective where you're doing a quote unquote virtualized array. This could be a central array, or it could be a server SAN hyperconverged type array. Where people usually say you probably still should separate them out is a couple places. Expandability of the disk itself, different things within Windows that you can do that are defined based on a disk level rather than on a file or folder level, can bring benefits to continue to separate them. Permissions within the environment, if you need to segregate, your antivirus vendor or your antivirus administrator away from the actual database files. Stuff like that is places where you probably still should separate them off to separate VMDKs or volumes within Windows.
Yeah, there were some older versions of Windows that you can't expand the OS disk.
Yeah.
Now I think with 8 and beyond you can, I'm pretty sure.
Mm-hmm.
But if you're still running some of those older versions of Windows and you need to for whatever reason, that's definitely a good reason to continue to segregate that information.
Yep.
We'll ask another question that's actually a SimpliVity-focused question, Brian,
yep.
That's from the audience. And it says, can you go through how redundancy is handled by SimpliVity? Once data is written, how is it copied to other nodes? How does the system handle different types of failure?
Okay. We actually, funny question. We actually have a blog post that's currently in the edit phase right now that hopefully will be getting posted either this week or next week that really goes into details. So I guess I don't want to steal too much thunder from that. And without the pretty graphics that the author of that post put into it, it's even a little bit more difficult to describe. But stay tuned to SimpliVity.com for that post. Essentially, what happens as a write comes in, it's going to be captured. We are a VSA, a virtual storage appliance type model. So there's a VM running on each node that is presenting the storage out through NFS. So a write's going to come, it's going to go to that VSA. That VSA is then going to commit that to, we actually have a hardware accelerator that we run on each of our nodes as well, that's presented directly through PCI pass-through to the VM. So it's going to commit it to DRAM and SSD that it exists on that accelerator card. It's going to commit it across a 10 gig network over to another node. It's going to do the exact same thing. It's going to commit it to DRAM and SSD. And then it acknowledges back to the VM. So at that point, the VM continues going forward. It knows its data is secure. It's across two different nodes. It's backed by batteries locally, so there's a lot of redundancy to protect it at that level. At that point, then the accelerator card is going to look at it. It's going to say, is this something we can dedupe? If it can be deduped, essentially just tosses it, creates a pointer record in our metadata table, which is all stored on SSD, so it's very, very quick to access and is protected for a loss of at least one SSD. If it needs to actually be written, if it's a brand new unique block on that particular node, it's going to look at it, it's going to compress it, it's going to queue it up, which is part of the optimization process. So once it's optimized, it flushes it down to spinning disk. Depending on the model, depends on what type of disk it is, but it is spinning disk. And at that point, it's, like I said, protected by the loss of at least 2 disks. Again, depends on the model. At that point, it's also compressed and optimized on the other node. So now it's then going to get flushed out to the spinning disk on that node. So now you've got the potential of losing an entire node, an entire server, as well as losing 2 disks and still have your data protected and available at that point. Or the potential of losing 2 disks in each host and still being able to present and use that data.
Thank you. That was a great answer.
It's even better with the whiteboard.
I bet. We have another question from the previous webinar, and I'll take a stab at this one. And the question is, in a hyperconverged offering, how do you avoid silos of wasted resources like storage? You know, when you think about hyperconvergence, you're taking sort of an appliance-based approach to expanding your data center. I like to use the phrase Lego-like. You basically get building blocks, and you add more blocks to your storage as to your environment as necessary. Now, what that means, though, is you're adding RAM, compute, networking, and storage to your environment each time you add a block. So you might say, well, I don't need more RAM, although we always need more RAM. I really need more storage. So what do I do? Am I going to waste all these resources? And the answer is you could. There's potential for wasting some resources in a hyperconverged environment. However, most vendors in the space are now creating differentiated blocks. Just like when you pick up a Lego set these days, not all the blocks look alike. In fact, some of them look pretty weird. But it's so that you can, with that Lego set, you can build what you want to be able to build and with more granularity. And you don't have a bunch of wasted pieces. The same thing is taking place in the hyperconverged world. There's more and more differentiation on the blocks that's happening. And even within the blocks themselves, you can often adjust the resources up and down a little bit to be able to sort of size that block the way that you want. So when you buy a new block, you can say, I need this much RAM, I want this much storage, to a certain point. They're not fully configurable like they would be in the physical server world. But again, the benefit here is not necessarily just saying, oh, I'm going to get exactly the CPU and exactly the RAM that I want. The benefit really comes into play around easier administration, easier scalability, and hopefully better overall workload performance in the environment. So there is a trade-off a little bit when it comes to resource utilization, but it can be manageable, and in a lot of cases, most cases, will outweigh the benefits will outweigh that potential downside for the environment. Brian, you want to expand on that a little bit? Do you hear that from customers a lot?
Yeah, I mean that's obviously a concern. The scalability of the platform as a whole is part of the key of the message. Being able to, and the other concern that usually comes along with that though is, you know, hey, what if I just need more compute? What if I just need more storage? And being able to do those independently. You know, that can be a limitation in some hyperconverged architectures. Like I mentioned before, within SimpliVity, we can bring in non-SimpliVity compute nodes and be able to just bring in raw CPU and memory, not bring in storage. Obviously, you lose some benefits not having the storage in the same box as the VMs running on. So those have to be balanced at that level. But you could. There's definitely a potential that if you have really big storage needs, that you're going to leave CPU laying on the table, not being used. That's not an uncommon problem to have in a virtual environment today. We have CPUs that are just becoming bigger and bigger and bigger. And while for a while their software was keeping up, software is just not keeping up today. And refresh cycles have gotten so short that um, you know, lots of environments actually are, I don't want to say standing still, but they're not growing their CPU needs as quickly as others might be, and therefore they're being forced to upgrade from four socket or sorry, not four socket, four cores to 8, 10, 12 cores nowadays, and not really needing that extra CPUs, but they need more memory requirements. So we are kind of in a situation where we're already seeing that happen. We just kind of shrug and say, CPU is just going to be, running 20% while our memory is running 80%. That definitely could happen, and that's key of architecting it. And part of the reason why you see pretty much all the hyperconverged, at least SimpliVity Nutanix, are very channel focused. So having a strong focus on architects and having technical people, and that's really the only way that we can scale, is to bring in partners that we trust that can properly architect it for customers and make sure that they're sized appropriately, not only for today but for where they're going in the future.
That's really good. Because that's a question I hear a lot, and I think that one of the answers to that question is maybe hyperconverged isn't for you. I mean,
Definitely.
it's not necessarily a niche opportunity, but if you're truly an outlier type use case where you've got massive data needs but tiny compute, or tons of compute but tiny storage, you may just fall outside the spectrum for a reasonable hyperconverged opportunity.
Hmm.
There's always a balance that has to be made on any kind of architectural decision, and if you're truly an outlier use case, that may not be the right solution. So nothing's a silver bullet, unfortunately,
Absolutely.
in the world of the data center.
And I do see some familiar names of people that know me in real life, and hopefully they would back me up in the statement that I'm always willing to say when something I'm offering, whether that be as a SimpliVity employee today or yesterday as a VAR, I'm not going to try and shoehorn something that's not going to work for the customer in the end. And I will readily admit that SimpliVity isn't going to work in every situation. Hyperconverged isn't going to work in every situation.
Right. We had another question that was interesting. How does vSphere DRS, this distributed resource scheduler, affect dynamic placing of VMDKs in a hyperconverged environment? Do you see potential for activity overload?
Yeah, that's a great question, and not one that a lot of people think about. And those of you who watch social media, the blogosphere side of things, have seen a few, I'll say, discussions go around about data locality, specifically around hyperconverged solutions, and that's key to the DRS piece of it. So those who don't know, vSphere DRS is the ability to automatically vMotion VMs around based on compute needs, in some aspects of storage, mainly around latency, to try and optimize the environment. And it's an amazing product that's been there for many releases now, that can help to optimize it to the point where you can actually fit more VMs into your infrastructure than you could without it. Um, the concern with DRS in a hyperconverged environment is, again, one of the advantages of hyperconverged is having CPU, the actual VM, running on the same platform that the disk, the data, is being stored on. And I don't think any of the hyperconverged vendors today are storing every VM on every node. I mean, that's while it gives you some really amazing redundancy, it is somewhat of a waste of resources. It kind of defeats part of the purpose of scale out. that being able to utilize them all efficiently across the different nodes. So at some point, if you vMotion a VM from one host to another host, you're going to be stuck in a situation where you might be accessing it across the network to get to the storage. So that is a concern. Some platforms will move the data along with it. So if it detects a vMotion, it'll say, hey, that VM's now running over there. I'm going to start moving blocks over to that new compute node. That could simply be through caching. It could be through actually moving the full stored VM over. Again, differences in platforms. I'm not going to speak to everybody's. From a SimpliVity perspective, we try and keep the VMs with the storage, and the reason why we do that is simply because we're trying to solve data problems. We're the number one thing that's holding data centers back more than anything else is storage, and the performance of storage, and the capacity, the amount of storage. And in order to reduce the number of IOPS, the amount of data being copied back and forth, if we move the VM, we try and keep the data local, then we're going to be doing pretty massive data copies across the network, and that's going to slow things down both on the individual disks that are containing that data and trying to read and write that data, but also across the network and potentially plugging those holes. Though that's rarely a concern at the pipe level. So, to kind of circle back to the original question. Yeah, there is definitely the potential of activity overload there. There's the potential of having to incur way more IOPS than are really necessary. There's the latency that's involved with having to go across a wire. There could be platform limitations within there that may or may not come into play as well.
Brian, we're going to move on to two VDI questions that came up in the last webinar, and I'm going to ask both questions because they're sort of related to one another. VDI, as you know, was one of the original popular use cases around hyperconvergence with some vendors.
Mm-hmm.
The question is, how would you summarize the first question is, how would you summarize the benefits of VDI or to VDI with hyperconverged solutions over legacy approaches for a sales pitch? Basically, in a quick down and dirty, what would the answers be?
Mm-hmm.
The next question is, how does hyperconvergence lend itself to not separating the VDI infrastructure from the rest of the environment? One of the things that I said in the previous webinar was that I'd seen organizations that originally had separate environments to manage to do VDI versus traditional servers because of the different I/O patterns. This was before hyperconvergence, and said, what's different in hyperconvergence that basically enables us to run side by side?
Okay. So I'll start first question first. The benefits of a hyperconverged with VDI is generally cost. One of the things that holds VDI back, and I've had, again, as a VAR, had customers in this situation where, well, we just can't justify the cost because we can buy a desktop for $100, and this VDI solution is going to cost us $150, $200, $300. Not calculating in the time savings on the back end, the OpEx costs. In a hyperconverged platform, if you consider all of the CapEx costs, you can oftentimes find a cost reduction there because you're not buying big, massive SAN, you're eliminating the switching infrastructure, being able to get that performance without having to build a really super huge, robust storage network.
Brian, can I interrupt for just a second on that?
Yeah,
I had
absolutely.
A client at a client site in Canada who was going to do VDI, and they started out with a solution that was basically based on tier 1 storage, tier 1 servers, and
Mm-hmm.
the price tag was almost $300,000 for, I forget how many desktops it was. I recommended to them at the time a hyperconverged solution, and they talked about it, and they did it, and they actually were able to get it for about a little bit over 1/3 the price of the original solution. And now they're moving their entire server environment over to that same solution. So it was a pretty powerful example of what can be done, in my opinion, with hyperconvergence.
Mm-hmm. Yeah,
sorry,
and
I didn't interrupt.
No, that's proof to my point. And that's just probably in a pure CapEx situation as well. Just sheerly, how much money do I have to write onto that check? The other side of it is from an OpEx perspective. Again, one of the goals is to simplify storage specifically with hyperconverged. being able to say, that overhead of having to manage the SAN is eliminated and is now more about managing virtual machines and virtual machine level storage rather than LUN level storage or array level storage. So there's an OpEx savings there as well that you would get with a hyperconverged over traditional. So then leading into the second question and kind of to your point, Scott, being able to start with VDI, moving the rest of the infrastructure in. Really, the hyperconverged, kind of going back to what are the benefits of hyperconverged, and do you have to be 100% virtualized in order to realize it? The more stuff you move onto a hyperconverged platform, especially one like ours that's doing such high levels of dedupe, being able to throw more things on there means you're going to get better dedupe, which means better utilization of disk, which means better performance overall. There's an advantage to throwing everything into the hyperconverged bucket. And more importantly, throwing it into a single hyperconverged bucket. Now, a lot of the reasons why customers split VDI off into its own infrastructure, and I dealt with many customers with this situation, is just the simple, I want to upgrade vSphere within a couple months of its release. Well, if you have, let's say, VMware View tangled up with all of your server infrastructure, which is a huge cost benefit savings because, depending on how much you want to segregate it, you may have 2 storage arrays, you may have 2 N+1 server infrastructures, you may have 2 vCenter servers. You can segregate them at many different levels, but you've duplicated the infrastructure at some level, and obviously there's a cost to that, but there's an advantage because if I completely segregate them, I can upgrade my server infrastructure completely independent of my VDI infrastructure, and they're no longer waiting for View to have support for the latest version of vSphere, and that was a commonplace. The management domain is considerably different for a VDI infrastructure than it is for a server infrastructure, and sometimes may have been built by a completely separate team. If the desktop team sees advantages in VDI and the server team says, yeah, we don't want anything to do with that, you go figure it out on your own. At that point, you're propagating silos that already exist in the infrastructure. So there's an issue in and of itself there. But you also have to consider that those political ramifications do exist, and sometimes you have to architect around those.
I have a follow-up question to a statement that I made earlier, which is, did my client converge the VDI nodes with the rest of the compute, or did they keep them siloed? Originally, they built the VDI environment as a silo of resources because they, again, for some of the reasons that Brian just mentioned. One was they were uncertain about how the hyperconverged infrastructure would actually operate because it was still new, even though it was a good demo, good sales pitch, but it was still relatively new at the time. So there was a question around how well it would work. They didn't want to impact the production virtual environment. So they actually ran the VDI environment side by side with the original environment, but it was a complete separate silo. What they're doing now is as they refresh the main server virtualization environment, they're actually adding blocks to the VDI environment, and they're basically combining the 2 environments. So they've sort of they used a project to bring hyperconvergence in, and then they're phasing it into a full environment on their refresh cycle. So that's the answer to that question. Brian, there's another question for you as a follow-up to the data protection question, kind of discussion from before. The person says it was very helpful, so that's good. Thank you.
Good.
Do you also have redundancy at the metadata level in any value domains, block or rack, kind of like Amazon availability domains?
So the metadata is stored on an SSD tier on each node, and that metadata layer is protected by the loss of at least 1 disk. So you should be able to lose 1 SSD disk and still be able to have it fully available. Across nodes, it's not, mainly because the dedupe is maintained per node. So each node has its own deduplication domain, essentially. So again, we don't want to dedupe across 2 nodes because that means there's only 1 copy across any 2 nodes. So each one is essentially maintained. Now, when it comes to data transfer, things moving back and forth, there's an advantage in the dedupe in that they can share their metatables to be able to say, hey, I've got this VM. It's constructed of these types of blocks. Which of these blocks do you have? And if you're only missing, think of a deck of cards. If I'm only missing the ace of hearts and the nine of diamonds, those are the only two blocks that need to be sent over for a full 52 block VM. So there's inherent advantages to deduplication and sharing the metadata between them.
One of the questions that comes up a lot, Brian, is around, am I out of a job? And this is one of the questions that we had from the previous webinar. And he said, I'm a sales guy, so probably a VAR. He goes, with hyperconvergence, is there a potential threat to the specific SAN guy or the specific server guy or the specific networking guy or gal? It might take away their livelihood. Who in the IT department should he try to target to have his discussion, given that he may be telling people, hey, by the way, I want to eliminate your job? I don't think it eliminates jobs, but
Yeah.
that's my opinion. But you want to talk about that? You've done
Yeah.
more sales on this than I have.
Yeah, absolutely. And this is a very common question when cloud was making its emergence too. Heard this a lot. So when it comes to, I've talked a lot, hyperconverged is going to come in, it's going to solve a lot of data problems. It's going to reduce the management of storage. So if I'm making my livelihood knowing LUNs and fiber channel switches and storage arrays, then yeah, there's somewhat of a risk there. Just like any job we have in IT, you should be prepared to morph and change. David Davis has talked about the infrastructure engineer rather than a storage engineer or a server engineer or a network engineer. Being able to be multidisciplined, being able to tie things together rather than just having that one little fiefdom. Who should you talk to from that perspective? Really, this is a decision that, excuse me, could get bogged down in a large environment due to the different silos and protection of different silos. I don't want to give up my storage domain. I like what I'm doing. But at the same time, a storage-only guy maybe, yeah, this virtualization thing is going to eat my lunch. I can see it coming. I know it's going to happen. It's time for me to start learning something new. And hey, if we go hyper-converged, storage is inherent in virtualization at this point. Why not start to make the transition over to being more of a virtualization engineer and start learning virtualization? And those of us that have been doing virtualization for a while can probably all attest to the fact that, yeah, I started off as a server guy, I started off as a network, as a storage guy, whatever. But now I know all those pieces very well. And, a lot of us could probably show up to any business and pretend to be one of those disciplines we didn't know before virtualization and people to probably pass off for quite a while. I'm no network guy by any means, but there's some customers I can talk circles around when it comes to networking, and that's simply due to my exposure to it through being a virtualization guy. So, who should you talk to as a representative trying to sell a hyperconverged solution? Just like always, you generally want to talk higher rather than lower because they're the ones that are really going to reap the benefits. But your virtualization guys are really going to be the ones that are going to be able to A, pick up the message the best, and B, probably be the least threatened by it.
I would agree with that wholeheartedly. And also, I'm in complete agreement on the rise of the infrastructure engineer. I see this as a person, like you said, who has more breadth but maybe less depth than the individual subject matter experts of the past. They're not going to have to create LUNs potentially. They're not going to have to do some of the stuff that had to be done in the past, so their brains can fit more broadly across the environment and have a little bit more focus at a higher level, maybe abstracted than we would have seen with some of the subject matter experts before. We're going to do two more questions. The first one I think is important given what happened to VMworld. The question is, what do you see the impact of VMware Evo Rail and Rack on existing hyperconverged solutions such as SimpliVity and Nutanix? And I have some opinions on that. First of all, I don't believe yet that VMware Evo Rail and Rack are fully baked solutions. And what I mean by that is they're missing what I see as core features that are necessary in larger environments. Most specifically, it's based on vSAN, and I think if it wasn't for that, I would actually have a little bit of a more of a positive opinion on these right now. And I think that VMware will, when vSAN 2.0 comes out and stuff like that, will make further inroads into this space. But without the ability to do things like deduplication and stuff like that, I think that they're behind the eight ball as far as the technology goes. But what I think they did do was their entry into this space immediately validated the space as a whole. If I were working for SimpliVity or Nutanix, I would have high-fived my partner when they came out with a hyperconverged solution, because I definitely see VMware's entry into this as saying this is viable. And some people were still skeptical, and some people are still skeptical. They're always going to be. But I see it as definitely a validation of the space. Brian, do you have any quick opinions on that?
Obviously at VMworld, I got asked that question a lot, especially being new to SimpliVity. I oftentimes got the, wow, do you still think you made the right decision question more often than not? And I agree. I think it definitely validates. VMware's not a startup. They behave like a startup in some ways, but they're a massive organization, and for them to have a solution like EvoRail put together and announced at VMworld is a big deal, and it's not something that they would have done lightly. So they obviously see a market there, and for a couple startups that are out there running around, been preaching this for several years now, I felt very validated that hyperconverged is a thing, and it's a big industry, and if you look at everybody's virtualizing, and everyone that virtualizes is a candidate for hyperconverged, so there's plenty of market out there, and I welcome the competition. It makes us all better.
Brian, thank you so much for being here today, and to our viewers, thank you for watching today. I hope that you learned a lot today, and continue to visit hyperconverged.org for new information about the world of hyperconverged infrastructure. Thank you very much.
Thanks, Scott.